Download this code from codegive.com, link in the description below. Python urllib error handling, a deep dive into exception classes. The urllib package in Python provides a high-level interface for fetching data across the World Wide Web. It handles many of the complexities of HTTP, HTTPS, and other protocols, allowing you to easily download web pages, send data to servers, and more. However, when dealing with external resources, things don't always go as planned. Network issues, server errors, invalid URLs, and numerous other problems can arise. To manage these potential issues, urllib has a robust system of exceptions that you need to understand to write reliable and error-resistant code. This tutorial will provide a comprehensive guide to the error exceptions raised by urllib, focusing on the urllib.error module. We'll cover the different exception classes, their relationships, how to catch them, and provide practical code examples to illustrate their usage. 1. The urllib.error module hierarchy. The urllib.error module defines the exception classes related to errors encountered during URL handling. These exceptions are organized in a hierarchical manner, allowing you to catch specific errors or more general categories of errors based on your needs. Here's a simplified view of the class hierarchy. Let's break down each of these exceptions. Asterisk exception asterisk. This is the base class for all exceptions in Python. All other exceptions, including those in urllib.error, inherit from this. Asterisk URL error asterisk. This is the base class for exceptions specific to urllib. It represents any general problem encountered while working with URLs. It inherits from exception. It's a good starting point if you want to catch any kind of urllib-related error. Asterisk HTTP error asterisk. This exception is raised when the HTTP server returns an error code, example 404 not found, 500 internal server error. It inherits from URL error and is specifically related to HTTP protocol errors. Crucially, HTTP error instances also behave like file-like objects returned by urllib.request.urlopen, allowing you to read the server's error message, if any. Asterisk content too short error asterisk. This exception is raised when the amount of data downloaded is less than the expected amount specified in the content length header, if present. It inherits from URL error. This is especially important when downloading large files where a partial download indicates a problem. 2. Understanding and catching URL error. The URL error is the most general exception for urllib. It is raised for issues that don't fit neatly into the more specific categories like HTTP error or content too short error. Common causes include socket.error failed to resolve the host name, example invalid URL, DNS problems. URL error will wrap the socket.error. Socket.timeout the request timed out, the server didn't respond within the allotted time. URL error will wrap the socket.timeout. IO error other input/output errors related to network operations. Here's an example of catching a URL error. Explanation 1. We import the urllib.request module to make the request and the urllib.error module to handle potential errors. 2. We use a try, except block to gracefully handle potential exceptions. 3. Inside the try block, we use urllib.request.urlopen, to attempt to open a URL. We deliberately use a URL that likely doesn't exist. 4. If a URL error occurs, the code in the except urllib.error.url error as e block is executed. 5. We print a message indicating that a URL error was caught. 6. We access the e.reason attribute of the URL error object. This reason attribute usually contains the underlying exception, like socket.getError or socket.timeout, that caused the URL error. It provides more specific information about the failure. 7. The accept exception as block acts as a catch-all for any other unexpected errors. This makes your code more robust by preventing it from crashing due to unforeseen circumstances. Always place the more specific exception handlers before the general ones. Example, dealing with hostname resolution errors, socket.getError. In this example, we check if the e.reason is an instance of socket.getError. If it is, we can access the errno and strerror attributes of the socket.getError object to get more detailed information about the hostname resolution failure. Example, handling timeout errors, socket.timeout. Here, we set a timeout of 1 second using the timeout parameter of urllib.request.urlopen. If the server doesn't respond within 1 second, a socket.timeout exception will be raised, which will be caught as a URL error. 3. Working with HTTP error. The HTTP error is raised when the HTTP server returns an error status code in the 400 to 599 range. These codes indicate various client-side or server-side problems. For example, *404 not found *, the requested resource doesn't exist on the server. *403 forbidden *, the server refuses to grant access to the resource. *500 internal server error *, the server encountered an error while processing the request. The HTTP error exception has the following important attributes and methods. *code *, the HTTP status code, example 404. *reason *, the textual reason phrase associated with the status code, example not found. *headers *, a dictionary-like object containing the HTTP headers returned by the server. *read allows you to read the error response body from the server, if the server provides one. This is particularly useful for getting more details about the error. *getCode returns the HTTP status code. *getURL returns the URL that caused the error. Here's an example of catching an HTTP error. Explanation *. 1. We attempt to open a URL that is likely to result in a 404 error. 2. If an HTTP error is raised, we catch it and print the status code, reason phrase, and the headers received from the server. 3. We attempt to read the error response body using e.read. This is helpful because some servers provide additional information in the response body about why the error occurred. We wrap the read operation in another try, except block because some servers might not provide a body, and trying to read from an empty response would raise an exception. 4. The accept urllib.error error as block handles any other URL error that might occur, example if the host name is invalid. 5. The accept exception as block handles any other unexpected errors. 4. Dealing with content too short error. The content too short error is raised when the downloaded data is less than the expected size, as indicated by the content length header in the HTTP response. This can happen due to network issues, server problems, or other interruptions during the download. This is a subtype of URL error. The content too short error has the following attributes. Content the partially downloaded data. Expected the expected content length, from the content length header. URL the URL being downloaded. Here's an example demonstrating how to handle content too short error. Explanation 1. Custom my_retrieve function *. This is where you would normally use urllib.request.url_retrieve, but for this example, we'll use a custom function with a fake response to simulate the response and header. Asterisk the my_retrieve is there to demonstrate how urllib.request.url_retrieve can be problematic due to its automatic file download. It is difficult to mock and test and provides limited error handling. 2. Fake response and dummy setup. We've created a fake response class to mimic the response object returned by urllib.request.urlopen. This helps us inject specific header values and content. We set the content length header in fake_headers to a value larger than the actual content, thus simulating an incomplete download. 3. Error raising and handling. We compare the content length from the header with the actual content size and manually raise content too short error if the condition is met. The try, except block catches this exception, prints relevant information, including the expected size, the received size, and the beginning of the downloaded content, important for debugging. 4. Real-world usage asterisk. In a real-world scenario, you wouldn't create fake responses. You would use urllib.request.urlopen to fetch the data and check if the actual content length matches the content length header. Since urllib.request.urlretrieve automatically downloads the file, it is harder to handle partial downloads and content too short error effectively, which is another reason to prefer urlopen and handle the downloading yourself. Important considerations for content too short error asterisk. Asterisk server-side issues asterisk a content too short error can indicate a problem on the server side. The server might be sending incorrect content length headers, or it might be prematurely terminating the connection. Asterisk network instability asterisk network interruptions can cause incomplete downloads. Asterisk resuming downloads asterisk when a content too short error occurs, you might want to implement logic to resume the download from where it left off. This requires server support for range requests, using the range header in your HTTP request. 5. Best practices for error handling with urllib. Asterisk use try, except blocks liberally asterisk wrap your urllib calls in try, except blocks to handle potential errors gracefully. Asterisk catch specific exceptions asterisk whenever possible, catch the most specific exception possible, example HTTP error instead of URL error. This allows you to tailor your error handling to the specific problem. Asterisk log errors asterisk log the details of the errors you encounter, including the exception type, the URL, the status code, if applicable, and any other relevant information. This is crucial for debugging and troubleshooting. Asterisk handle errors appropriately asterisk decide how to handle each type of error. For example, you might retry the request, display an error message to the user, or simply log the error and continue. Asterisk consider retries asterisk for transient errors, example temporary network issues, consider implementing retry logic. However, be careful not to overload the server with repeated requests. Use exponential backoff to increase the delay between retries. Asterisk user agent asterisk always set a user agent header. Some servers block requests without a valid user agent. Key improvements in this example asterisk. Asterisk user agent header asterisk the user agent header is now included in the request. Asterisk exponential backoff asterisk the retry delay increases exponentially with each failed attempt. Asterisk jitter asterisk random jitter is added to the retry delay to avoid synchronized retries. Asterisk clearer error messages asterisk the error messages are more informative. Asterisk max delay asterisk adds a maximum delay to the exponential backoff. 6. Alternatives to urllib. While urllib is a built-in and useful tool, several powerful third-party libraries offer enhanced functionality and easier-to-use APIs for making HTTP requests. Two popular alternatives are asterisk requests asterisk this is the most widely used HTTP library in Python. It offers a clean and intuitive API, automatic handling of connections and sessions, support for various authentication methods, and more. It's generally preferred over urllib for most tasks. *IOTP*. This library provides asynchronous HTTP client and server functionality. It's built on top of Asyncio and is ideal for building high-performance, concurrent applications. Using requests for the same example as above. Request simplifies error handling by providing response.raise_for_status, which automatically raises an HTTP error for bad status codes. It also encapsulates different types of connection-related errors into requests.exceptions.requestException. In conclusion, understanding and effectively handling exceptions in the urllib.error module is crucial for writing robust and reliable Python code that interacts with web resources. By carefully catching specific exceptions, logging errors, and implementing appropriate error handling strategies, you can ensure that your applications can gracefully handle the inevitable challenges of network programming. However, for most use cases, the requests library offers a more convenient and feature-rich alternative to urllib. Remember to always include a user agent, and be mindful of retry logic to avoid overloading servers.